we're on this page. So this one here says, we're going to read the question. There are 30 people in class. Yep. Okay, there are 30 people in class. 15 are in math, 17 are in English, 30 are in neither math or English. That screams Venn diagram, doesn't it? Okay. So we would go, hey, I don't know the middle, but I do know math, I know English separately, and I know neither, and I know total. So I can go 15 plus 17, or all the people who put a ticket in for I'm in math, put a ticket in for I'm in English. There's 3 who put a ticket in for I'm in nothing. Okay? When I add that up, I'm going to get 35. So technically there was 35 tickets put into this hat, let's say, or this box, correct? I'm in English, I'm in math, I'm in neither. So how many people doubled up? 5, right? Because there's 30 in total. So I subtract the 30 and I get 5. Okay. So I have 5 here. Then I have math and I have English. We've done absolutely nothing different from what we did in set theory. In math, there should be 15. So how many are in math only? 10. In English, there should be 17. So how many are in English only? 12. And by themselves? 3. Okay? Now, if I said how many are in English only, you'd tell me 12. If I said how many are in math only, you'd tell me 10. If I said how many are in math and English, you'd say 5. If I said how many are in math or English, you'd say 10 and 12, 22 plus 5, 27. We agree? If this is a set theory question, boom, that's all it would be. So this is a plain old Venn diagram. We agree? Nothing crazy from anything we've done before. The difference comes in the questions. Determine the probability of. The probability of is just give me my Venn diagram answer, and I just have to put it over the total every time. Correct? That's the difference between probability. So of being in math or English. How many are in math or English? The snowman. How many are in math or English? 27. We agree? So if I asked for how many are in math or English, you'd give me 27. If I say the probability of math or English, you'd give me 27 over 30. Which I can take a 3 out of both, so it gets me 9 out of 10. Which as a decimal is 0.9. Right? So the only difference with a Venn diagram, a plain Venn diagram with probabilities, you just divide by the total. Nothing crazy, right? Okay. What's the probability of being in math and English? How many are in math and English? The eyeball. There are 5 out of 30. And that reduces to 1/6, which gets me what is to 2 decimal places? 0.17, right? Because it'd be 16666. Okay, math only. How many are in math only? 10 out of 30. 1/3, which is 0.33. Now, what do we know about odds? Odds always add to what? The total. We agree? Odds add to total. I'm going to write that. Odds add to total. What is the total in this instance? Total equals 30 people. We agree? Okay. So the odds would be really easy for this one. If I know one of the letters, the other one just has to add to 30. Correct? Boom. Have my odds. We agree? Okay. So this one says odds in favor. Odds in favor means it comes first. Odds in favor of being in math. So math comes first. And what would come second? Not math. Okay. So we need to figure out how many are in math. Did it say math only? No, it said math. How many are in math? There's 15. We agree? So how many would be in not math then? 15, because this has to add to what? 30. Let's check it. So if there are 15 in math, the 10 and the 5, So I cover that up. How many are not math? 15, 12, and 3. Correct? So it does show it on the Venn diagram as well. Now, how do we reduce 15 to 15? What do we get? 1 to 1 would actually be the answer they're going to look for on your multiple. Okay? We always reduce them. Now, I know that doesn't add to 30, but your 15 and 15 does. So reduce isn't going to add to your total. Okay. What was the next one? Odds against English. Odds against means it comes second. So English is second, and then not English first. How many are in English? 12 and 5, right? So 17. So how many are not in English? 13, because this bad boy better add to 30, the total. Make sense? Got it? Okay, grab out a separate sheet of paper. If you don't have one, put your hand up. I'll give you a piece of paper. You're going to do this question. Got it? Okay. In a group of 40 people, ten people like cheeseburgers. That should have any burgers. 30 people like chicken burgers. And 5 people like neither. Sounds straight up like a Venn diagram question, correct? Yeah. Nope. Now, A, the probability of liking cheeseburgers only. I'm struggling with waiting energy. So, I gave you the singles. I gave you liking chicken burgers. Gave you liking cheeseburgers. I gave you the neither. And I gave you the total. So we can find the and, correct? So, 10 people put in tickets for cheeseburgers into the hat. 30 put chicken burgers. 5 put neither. That's how many? 45, which means 5 doubled up. 5 like chicken burgers and cheeseburgers, right? So, cheese, chicken, 5 in the middle. How many like cheese only? 10 like cheese. So how many like cheese only? 5. How many like chicken only? 25. How many like neither? 5. I made it nice, easy numbers. If we add those up, we should get 40, correct? If we don't get 40 when we add up our Venn diagram, we did something wrong, because it should total to 40. So what's the probability of like cheeseburgers only? How many? Make sure your phones are away. 5 out of 40, which reduces to 1 out of 8, which reduces to 0.125. Okay, so I'll go 1 and 3. I'm just going to do 10. Hundredths, not tenths. Probability of cheese and chicken. How many are in cheese and chicken? There's 5, correct? Out of 40. It's the same answer. 1/8. 0.13. Now odds. Odds should total to what in this question? It should total to 40, correct? So if we have one, we have the other. Because it should add to 40. So odds against means whatever comes after it comes second. Odds against liking a chicken burger. So chicken burger would come second, and not chicken would come first. Now, not chicken doesn't mean cheese. Not chicken means everything that's not in chicken, correct? So that's where people get it wrong. So how many are in chicken? How many like chicken? Besides you, how many on here like chicken? 30, right? So how many do not like chicken? 10, because it should add to 40. And if I cover up the chicken, what do I have left? 5 and 5, which is 10. So that's going to reduce 1 to 3. Okay? So there's something called mutually exclusive and not mutually exclusive. Mutually exclusive means no overlap. We're going to write that down. Mutually exclusive means you're mutually exclusive, which means you have no overlap. You're not dating like 4 people, right? You're mutually exclusive, no overlap. Think about it in relationships. Mutually exclusive means you're not free to date others. You're mutually exclusive, no overlap with others. Yeah. And then not mutually exclusive means overlap. So this Venn diagram above, is it mutually exclusive or not mutually exclusive? Not mutually exclusive, you're right, because there's an overlap in it, right? Not mutually exclusive means they are overlapping. We agree? The only way a Venn diagram would be mutually exclusive, this is for Venns, would be if they were like 2 circles not overlapping, correct? And then not mutually exclusive is almost 99% of Venn diagrams that we've drawn anyways, because they overlap, correct? Make sense? Okay, the only Venn diagram we've looked so far is a plain old Venn diagram, and then we find the probability by dividing by the total. We agree? Okay, we're going to go back to our sheet. The next Venn diagram, I don't just give you numbers. The next Venn diagram, I actually give you probabilities. Still sounds like a Venn diagram, but instead of just giving you like 7, 9, 8, I give you the probability of it being there. Okay? So there's basic Venn diagrams. This is just a normal Venn diagram probability. The second one, no good. The second one is a probability Venn diagram. How do you know? It gives you probabilities. Diagram. Probability Venn diagrams total to 1. Because when you add up all probabilities, it should total to 1. We agree? If they gave you the probabilities in percents, it should total to what? 100. That's the only difference. Okay? So they can give you 2 types of Venns. A normal Venn, where it just sounds like the previous one, and then a probability Venn. So this one here says, people at a grocery store are surveyed on whether they ski or skate. They determined the probability of skating is 0.4. The probability of skiing is 0.65. The probability of doing neither is 0.05. So it sounds like a Venn diagram, correct? But it just has the word probability. same thing as before, but now they need to total to 1. Last time they needed to total to 30 for the first question, right? Now they have to total to 1. So, do they count to more than 1? I gave you separates, I gave you neithers, and you know total is 1 because it's probabilities, correct? So let's see. So we go 0.4 plus 0.65 plus 0.05, and I get 1.1 is what I end up with. So how much too much is that? 0.1. So that's going to be what they're going to share in the middle. Okay. You say the probability of skating is 0.4. So what's the probability of skating only? 0.3. We're not doing it any differently, right? Still subtracting just like before. Probability of skiing is 0.5. What's the probability of skiing only? 0.55. And how much is on the outside? 0.05. If I add these up, when it's a probability Venn diagram, they should add up to what? 1. If they don't, you messed up. Okay? 0.5 plus 0.3 plus 0.1 plus 0.55 is 1. So we're good. We can answer this. Now the probability Venn diagrams rock, because if I ask you for the probability of it, they already have them. What's the probability of skating only? 0.3. What's the probability of skiing only? 0.55. What's the probability of neither? 0.05. They already have all the probabilities done for you. Life is good. I don't have to divide by 30. I got a probability. Correct? So, what's the probability of skiing or skating? Or is the what shape on a Venn diagram? The snowman. Count up the snowman ones. Done. That's it. So 0.55 plus 0.1 is 0.65 plus 0.3 is 0.95. Done. I don't have to divide by anything because it is the probability. Correct? Determine the probability of skiing and skating. What's in the end? 0.1. Determine the probability of skating only. 0.3. Determine the odds in favor of skating. Odds in favor means it comes first. Skating. So I'm going to do skating first. And then what comes next? Not skating. And not skating is not skiing. Not skating is everything that's not in the skating, correct? So what should our odds on a probability Venn diagram add up to? 1. Exactly. So skating, how many are in skating? 0.4. How many are in not skating then? 0.6. Because they should total to 1. We agree? Well, let's look. In skating, in 0.4, I cover that up. 0.55 plus 0.5 is 0.6, right? Now type that in. Go 0.4, so 0.4 divided by 0.6. You can type it in as a division. 0.4 divided by 0.6. Math, enter, enter. 0.4 divided by 0.6. Riley, your phone's going to become mine. I don't want it, so please don't make me take it. 0.4 divided by 0.6 is? Math, enter, enter is? 2/3. So 2 to 3. The calculator will reduce it for you. Yep. Yeah. Because this stuff is new for the next part. We're going to do a probability then new. Okay. Make sense? We agree? All right. Is this a mutually exclusive Venn diagram or not mutually exclusive? This is not mutually exclusive. And why is it not mutually exclusive? Because there is overlap. There are some people who skate and ski, right? If the skate and ski spot has some number in it, they overlap. There's some people that do both, and if there's people who do both, it's mutually exclusive. Not mutually exclusive, sorry. Going back to our paper. Go to your extra sheet. So I'm going to go the probability James, I'll do skating again. Skates only is 0.1. Skates and skis . 0.3. So sorry, probability. Skates or skis, 0.1. Probability skates or skis. I don't know. It looks, is that skis? It just doesn't even look right. It looks like, I know, but when you put just an S, it looks even worse. Is it just S-K-I? You can read it, whether it's spelled right or not. Google it. I swear, I don't know what this is. See, that's skies. Is skis 2 I's and an S? What is the plural form of skis? Skis. Also to ski. It's just an S, which is what I did, but it looks so wrong. What it is. Because this is skies. I'm like, it doesn't even. Yep. That skis. It so looks so weird. Probability skates and skis 0.3. Probability skates or skis is 0.8. A. Determine the probability to skis only. Determine the probability in either skates or skis. Determine the odds in favor of skiing. Should be a dot. So we have skiing and skating. And we know that they say probability in the question. So if they say probability in the question, our Venn diagram needs to add to 1. We know that. So we have skiing, skating, or the other way, it doesn't matter. Now, I know that skates only is 0.1, and I can put that in. Whenever it's only, you can put those in first, right? Because they're only in one little area. So I can go 0.1 here. And then it says skis and skates is 0.3, so I can put that in one area. And then or is 0.8, and or is the whole snowman, correct? So the snowman should add up to 0.8. It already adds up to 0.4, so skiing only would be 0.4. And then how many would be in neither? 0.2, because the whole thing should add to 1, right? Whenever it's a probability Venn, it adds to 1. If it's in percent, it adds to 100. That's the only difference. Determine the probability he skis only. 0.4. When you're done filling in these Venn diagrams, the answers are really easy because the probabilities are done for you already, right? Determine the probability he skates, neither skates nor skis. 0.2. Determine the odds in favor of skiing. So odds in favor means it comes first, and it's skiing first. The opposite of skiing is not skating. The opposite of skiing is not skiing. Right? So how many skiings are there? 0.7. How many not skiings? Then it would be 0.3, because these should add to 1, correct? Also, if I cover up the skiing, how much is left? 0.2 and 0.1, which is 0.3. When you type those in, what do they get you? 0.7 divided by 0.3, math enter. Gets you 7/3, correct? Or in this case, 7/3. We agree? Was this mutually exclusive or not mutually exclusive? Not mutually exclusive because there's overlap. Okay, go back to your sheet. So there's two things we can do in mutually exclusive and not mutually exclusive. I can give you a plain old Venn diagram, ask you probabilities, give you a probability Venn diagram, ask you probabilities, right? See those two? This is the third thing I can do. You didn't even, yep. You can do these questions without me even talking to you about them, but you wouldn't know what mutually exclusive or not mutually exclusive is. So let's look at these ones here. It says determine the probability of the following, and then determine if they're mutually exclusive or not, which we'll talk about, from a deck of 52 cards. A king or a 3? A king or a 3? How many kings are there? 4. So I'm going to write this down. I always put my knowledge base I have. 4 kings. And then how many 3s? 4 3s. Now we decide if mutually exclusive or not mutually exclusive based on if they ask me for a probability with an or statement. Okay? This is when they give me two things, something or something. When it has an or in it. And an or means I do what? I add them. We agree? Okay. Kings and queens. Kings and 3s. I mean, I read queen on the second one. Kings and 3s. Do they overlap at all? Are there any kings that are 3s and 3s that are kings? No, there's no such thing. So is this mutually exclusive or not? It's mutually exclusive. Okay, how many cards is that? How many kings or 3s are there in the deck? 4 and 4 is 8. So it would be 8 out of what? 52. Reduce that. What's 8 divided by 52? Math enter. What does it reduce to? What does it reduce to as a decimal? It's the nearest hundredth. 0 decimal. And as a percent, it would be 15%. Correct? They asked for that. Okay. What about a queen or a heart? Let's write it down. So how many queens are there? There are 4 queens. We know that. How many hearts are there? 13 hearts. Now what I need to ask myself every single time there's an or, do you see this or here? Is if it's mutually exclusive or not. What does that mean? How many queen hearts are there? There's 1. Which means there's 1 that overlaps. Do we agree? There's one that overlaps, we agree? So is this mutually exclusive or not? It's not mutually exclusive. So when it's not mutually exclusive, we can actually add the probabilities of these two up and subtract off the overlap. Watch. So queens, 4 out of 52. We agree? Hearts. What's hearts? 13 out of 52. What's the overlap? 1 out of 52. So how many is that out of 52? 16. You got it. And you guys might have done it with just knowledge, knowing, hey, I have 4 queens, I have 13 hearts, one of them overlaps, that's 16 new cards, right? Technically, it's 16 different cards. I can't say 17 because there's not 17 different cards, there's 16, one of them overlaps, right? So when it's mutually exclusive, you can just add the two probabilities. So I could go 4 out of 52 plus 4 out of 52, and I get 8 out of 52, which was the exact same answer as the previous question, wasn't it? Yeah? But when they're not mutually exclusive, I have to add the two probabilities and subtract off the overlap. And when do we do that? When it has the word or in between them. Or. Okay? Let's look at the next one. Club or a black card. Let's look at it. How many clubs are there? There are 13 clubs. How many black cards? 26 black cards. Okay, how many club black cards? Actually, all the clubs are black cards, aren't they? And I do this lineup when it says or. Do you see that? When it says or. Oh, crud, there's overlap, isn't there? Actually, all the clubs are black cards. There's a lot of overlap. So is this mutually exclusive or not? It's not mutually exclusive. So what do? I add the probabilities. So I go 13 out of 52 for clubs. And then I go 26 out of 52 for black. And because they're not mutually exclusive, I have to subtract off the overlap, which happens to be 13 out of 52. So I get 26 out of 52 or a half, or 0.5. So when it's not mutually exclusive, I have to subtract off the ones that double, right? Because I counted 13 clubs, and I counted those 13 clubs again in the black. So I have to take them off. You guys try D. Okay, how many face cards? Face cards are jack, queens, and kings, and 4 suits. How many face cards? 12. Good answer. From no one. How many hearts? Then we always have to do the last one has to be face card hearts. So basically, how many face cards are hearts? 3, right? If that last one is not a 0, there's overlap. We agree? If the last one with the slash is not 0, there's overlap. Yes? So it's not mutually exclusive. And how do we know to check for that? The word or. See that word or in it? The word or. So what do we do when it's overlapped? We go 12 out of 52 plus 13 out of 52. Subtract off 3 out of 52. And we actually get 22 out of 52, which reduces to, what do we get? Yep, which reduces to what is it? 100. Okay, we're going to look at spinner questions. Determine the probability of the following. Determine if they're mutually exclusive or not. How do we know to check? Or. Probability of this or this. Probability of this or this. Probability of this or this. Right? Spinner with 6 spaces, and they'll say equally sized spaces. They'll always say that. Because if it's not equal sized spaces, the probability wouldn't be equal for each one, right? Which would make a totally different ballgame. So we have a 6-sided spinner. That was a bad decision. Okay. Pretend those are even. 1, 2, 3, 4, 5, 6. We agree. Okay. So we want odd or 4. Okay. Same thing. Instead of cards, we have a spinner. How many odd? How many of those numbers are odd? 3. How many are 4? 1. How many are odd / 4? How many odd numbers are 4? 0. Is 4 odd? No. So what is this question? Mutually exclusive or not mutually exclusive? Mutually, there's no overlap, right? Odd 4? There is none. So it's mutually exclusive. When it's mutually exclusive, you do it the same as the not mutually exclusive, except you just don't have subtracting off overlap. So we're going to have odd, which is 3 out of how many? 6, plus 4, which is 1 out of 6. And no subtractions, correct? Because there's no overlap. So it's going to equal 4 out of 6, which reduces to 2 out of 3, which gets me 0.67, I believe. Multiples of 3. What are the multiples of 3? Start at 3, go up by 3, right? So 3, 6 would be the only ones with multiples of 3 in here. Factors of 12. What are the factors of 12? 1 and 12. 2, 6, 3, 4. So that's great. These are all factors of 12, but which ones fit on the wheel? 1, 2, 3, 4, 6. That one doesn't fit on the wheel, correct? So try these two out. How many even? How many of them are even? 3. How many of them are multiples of 3? 2. How many are even / multiples of 3? How many of them are even and multiples of 3? 1, the 6, correct? So what is this one? Mutually exclusive or not? Not mutually exclusive. Okay. So when it's not mutually exclusive, we do 3 out of total 6 plus 2 out of 6. And then we subtract off the 1 out of 6 that doubles up. It's always going to be out of 6. We just do the work to the top, right? If you need common denominators, we already have it. 3 plus 2 is 5 minus 1 is 4, which is 2/3 again, which is 0.67. Odd. How many of them are odd? 3. How many of them are factors of 12? I stated it. 1, 2, 3, 4, 5. The only one that's not a factor of 12 is 5, right? Then we have to do the combined. Odd, and then factors of 12. So sometimes it's nice to list them. That's why I listed the factors of 12 here. How many of factors of 12 are odd? 1 and 3. So 2 of them, correct? Uh-oh. I filled in not 0 here. If I fill in anything but 0 here, it's not mutually exclusive, right? There's overlap. So we're going to go 3 out of 6 for odd, plus 5 out of 6 for factors of 12, minus the 2 numbers that overlap. And so it's over 6. And I go 3 plus 5 is 8, minus 2 is 6. Wait, the probability is 1? How is that possible? Odd or factors of 12 actually cover every number, correct? So that's why it's 1 out of 1, or 6 out of 6, right? If you haven't done this already, please do these 5, 6, and 7. These have nothing to do with nothing to do with mutually exclusive or not. They're the previous material. 5, 6, and 7. They're going to be your daily quiz at the beginning of class tomorrow. So make sure you're done them. 5, 6, and 7. Okay? Most of you are done them. If you're not, finish them. 5, 6, and 7.